Welcome, everyone, to today's essential lesson on task execution tracking and history in distributed systems. In the complex world of modern software, where systems are increasingly distributed and asynchronous, understanding the life cycle of your tasks isn't just a good idea, it's absolutely critical. By the end of the session, you'll gain practical insights that will empower you to build more robust, observable, and performant applications. Specifically, our learning objectives are designed to give you a comprehensive grasp of this topic. First, you will understand the criticality of task execution tracking, why it's a non-negotiable component in any serious production environment. Second, you'll grasp the core components of a task execution entity, which is the fundamental building block for keeping records of your tasks. Third, we'll explore how this tracking mechanism integrates into a distributed system architecture, ensuring seamless operation across multiple services and nodes. And finally, you'll identify key production considerations for robust tracking, preparing you for the real-world challenges of scaling and maintaining such a system. Let's dive in and uncover why this truly matters more than you might think. Imagine running a bustling coffee shop where customers place orders, but you have no system to check if the barista actually made the drinks, how long it took, or if anything went wrong. That's the kind of chaos that erupts in distributed task schedulers without proper execution tracking. Without visibility, you face three major real-world problems. First, the invisible failure problem. Tasks can fail silently due to network glitches, resource exhaustion, or subtle application bugs. These failures remain hidden until customers complain or critical business processes grind to a halt. Second, the performance optimization challenge. How can you fine-tune your task scheduling or resource allocation if you don't know which tasks consistently take longer than expected? Execution tracking provides the vital data for intelligent decision-making. And third, the debugging nightmare. When something inevitably goes wrong in production at 2 a.m., execution history acts as your time machine, allowing you to understand exactly what happened, when, and why. This isn't just about convenience, it's about system stability and business continuity. To solve these problems, we introduce the task execution entity. Think of it as the flight recorder for every single task running in your distributed system, capturing every critical detail from start to finish. This permanent record is crucial for auditing, monitoring, and debugging. Let's break down its key components. Every task execution needs an execution ID, a unique identifier that often links back to our idempotency strategies, preventing duplicate records. It also contains timing data, recording the precise start time, end time, and calculated duration of the task. Status tracking tells us the current state, from pending to running, and finally to success or failed. Outcome details provide more granular information about the task's completion status, including success failure status and any relevant error contexts. Lastly, resource metrics capture vital performance indicators like memory usage and CPU time, giving you insight into resource consumption. Together, these components form a comprehensive picture of each task's journey. Now, let's see how this task execution tracking system integrates with other vital components of your distributed architecture. It provides seamless integration with concepts like idempotency and future status management systems, acting as the persistent layer for state transitions. In a multi-node environment, execution tracking becomes the distributed coordination source of truth, preventing conflicts and ensuring proper cleanup of abandoned tasks. The data flow lifecycle for a task execution record is straightforward. It starts as pending upon submission, transitions to running when a node picks it up, can have optional progress updates for long-running tasks, and finally concludes with a success or failed status. Crucially, this entire process uses asynchronous processing to avoid adding significant overhead or impacting the performance of the actual tasks being executed. This thoughtful integration ensures that tracking is a powerful yet non-intrusive part of your system. Implementing robust task execution tracking comes with practical considerations you must plan for in production. First, there's a minimal performance impact. A well-optimized system adds only about 2 to 5 milliseconds of overhead per task, a negligible cost compared to the immense benefits of observability. Second, storage growth is a real factor. A system processing 1 million tasks daily can generate roughly 100 megabytes of execution data per day. You need a solid plan for database scaling and archival strategies to manage this. Third, query optimization becomes critical. Execution history tables grow very large very quickly. Proper indexing on fields like execution time, task ID, and status is essential for maintaining responsive dashboards and analytics. In summary, we've explored why task execution tracking is vital, the core components of the task execution entity, how it integrates into your system, and the practical challenges of production. This knowledge empowers you to build systems that are not just functional, but also resilient and observable. As a final self-assessment, consider this. How would you design a robust archival strategy for execution history that balances data retention with performance and storage costs?